All right, so this is, we're going to go over the homework from last night, and we did number 1 yesterday during the Zoom class, I believe. Yep, we did. So we are going to now move on to number 2. So I'm just going to fill in the missing pieces on these triangles here. So we've got angle here, angle here. All right, so this triangle was already fully solved. So we go into our new triangle. We get that this angle here has to be 26 degrees. We get that this angle here is 14 degrees. That angle P is 140 degrees. So in order to find the scale factor here, you really had to deal with the 6 7/10 and the 13.4. Well, that gave us a scale factor there of 2, so we knew that we could take each one of these side lengths and multiply it by 2. So this gave us 9 8/10 and 5 6/10. All right, so then we're going to move on to number 3. On number 3, we had a situation where our triple arc was 59 degrees, our single arc was 79 degrees, and our double arc was 42 degrees. And remember, ABC went to this figure here, so this figure's gotten bigger. B to C was the single to triple, so I compare it to my single to triple, that 5.8. And again, it looks like our scale factor is 2. So from my 3 to my, I guess it'll be 1/2 to bring it down to the smaller figure here. So here I'm going to, I've got my 3 to my 1. So 3 to 1 is the side length here. So this is going to be a side length of 4 1/10, which means that this is going to go with our 7 and 2, and that's going to be 3 6/10. Then we have our last problem like this one. So we did have to use, so our single arc here is 41. We don't have to use triangle sum. 98 is here. That's a 96, even though I said 98. And then 43 is there. All right, so I already have my hypotenuse for each one of these. So when I deal with that hypotenuse, I realize that if I take 6 and I multiply it by 5/3, that's how I get 10. So I'm going to take 7, I'm going to divide it by 5/3, and I'm going to get 4 2/10 here. Then I'm going to take my 3 3/10, I'm going to multiply it by 5/3, and I'm going to end up with 5 5/10 down there. All right, so number 5, when we go to analyze this one, we do end up with a dilation here. And the scale factor of this dilation, scale factor of this dilation is 2.5 or 5/2. So if you found a side length, for instance, if you found this side length here, you would have gotten 2√5. If you found this side length here, you would have gotten 5√5. And when you divided your new divided by old, you would have ended up with 5/2. So that pattern would have continued around the entire figure. All right, we're going to move on to number 6. So for number 6, you already know that these, we should have proved that these are congruent because they're the same size. So that's technically a dilation with a scale factor of 1. Then the next thing that is going to have happened here is that this figure is almost, it is, I don't know if you can tell yet, it would actually be a mirror image, I believe. Yep, absolutely. So this is just a mirror image here. We know that F goes with C. I know that D goes with A, that E goes with B. So what's happened here is a reflection and a translation. So if I wanted, if it wants to know what happened here, I know this is my new figure. So my original figure has translated 1, 2, 3, 4 units left. So that's going to be x minus 4. And you could leave it at that exact same level and make it just x minus 4y as your translation there, because that's going to put point C right here. Going to put point A 1, 2, 3, 4 right here, and put point B 1, 2, 3, 4 right here. Well, now it's easier to see here that I have this mirror image. Well, it was until I did that. But now you need to create a reflection. So you could reflect it over the x-axis. If you reflect it over the x-axis, then you're going to have to translate it down. Another option at this point would be just to reflect it over the line. Well, we're at 1 and that's at 5. Ooh, so that's going to be and in between, because we've got 1, 2, 3, 4, 5, 6. Yep. Oh, no, right here, because that's going to be 3 above, 1, 2, 3, 3 below, 1, 2, 3. So that line right there is going to be y is equal to 2. So you could reflect it over this horizontal line, y is equal to 2. Another option here would be to reflect it here over the x-axis, and then which would put it here, and then you would have to translate it down 4 units. 1, 2, 3, 4. All right, number 7 we did as a class. For number 8, you again have a situation where when you test the side lengths, they're the same size. So to figure out what happens, take a point. So A was at 3, 4. Well, A is going to become point D. Well, D is at -3, -4. So it looks like both of the signs just changed. So this might be a 180-degree rotation. Let's see. C is at 4, 8. That would make a point. That would make it at -4, -8. There it is. B is at -4, 7. That would be +4, -7. Absolutely. So what we have right there is just a rotation with a scale factor of 1. The rotation is 180 degrees. Then for your last question here, you had to go in and assess these figures. And I hope that you did actually assess these figures, because what you end up getting here is that line segment AB is 2√10. You get that line segment BC is 4√2. And that line segment AC is the square root of 116. Then on this other figure, you get that DE is 3√5. You get that side DF is still the square root of 116. And you get that this one here is the square root of 41. So you can already tell that since this side length hasn't changed, if these are similar, these side lengths wouldn't have been able to change either, and they have changed. So this is going to be, these are not, so that's special. These are not similar because you have a situation where the side length doesn't apply to or the scale factor does not apply to all 3 sides. So at this point, we're going to skip ahead to look at our lesson for today, which is on page 19, 119. All right, so on page 119, you're going to get to something that looks like this, and it's really important that you know what angle criterion says. So fill this in. Angle criterion tells us that if 2 corresponding angles in 2 triangles are congruent, if 2 corresponding angles in 2 triangles are congruent, the figures are similar. All right, so it is important to recognize that the three congruent angles, because if two of them are congruent, then the third one's obviously congruent as well because of triangle sum. But three congruent angles does not prove congruence. Three congruent angles prove similarity. And the easiest way for me to remember that is that all equilateral triangles have 360-degree angles, and not all 60-degree or not all equilateral triangles are the exact same size. All right, so they are asking us to explain why the triangles are similar and write a similarity statement. Well, we're not going to do a lot of explaining here because what we already know is that angle A is congruent to angle D, and they're in different triangles. And I know that angle B is congruent to angle E because of the double arcs. Because I know that these two angles are congruent to these two angles, I already know that these triangles are similar. Now, an important thing to note is you also know something about these angles. These angles are vertical angles. So technically, you already know without even thinking about angle-angle similarity, because all three angles here are the same. So if it's asking us to state the conclusion, it's just asking us, how can you name the triangles? So we'd have to go 1 to 2 to 3. So I would say triangle ABC is similar to, not congruent, and that was 1, 2, 3. So I'm going to go 1, 2, 3. So that's going to be, it's similar to triangle DEC. So again, what I now know is that the side lengths here would be proportional. A dilation would have happened between them because they are similar. So the only way that you can change the side lengths is always going to be through a proportional relationship. All right, so that word proportional is going to be important here because what we are going to be doing sort of through the rest of the geometry unit, it really is sort of through the rest of this whole unit, which is only 2 more lessons. Nope, 3 more lessons. So, but all of those are going to be having us use proportions. So in this question, we know that the figures are similar and we're trying to find the length of DF. Now, absolutely, I could just figure out the relationship between this and then apply it to this figure here. But the easier way, and the way that's going to allow you to kind of do it in one step that's going to lead you into where we're going next, is to set up a proportion. So the way that I set up proportions with triangles is I always compare the two within the proportion. So I know that the short leg of triangle ABC is 3 4/10. So I'm going to put that, actually, let me set up what I'm doing. So I'm putting the short leg of ABC over the short leg of DEF. So that's going to be here, 2 7/200. Well, now I already know the long leg of AC. So I'm going to put the long leg of AC. So I'm putting my information about AC in the numerator and my information about DF in the denominator. So this is short, short over long, long. So I'm going to have 6.9 here. Make sure that the 2 in the numerator came from the same triangle, and that's going to be over DF. So that's going to be long of DEF. And I don't know that, so I'm going to put in an X. So what I'm going to do here is I'm going to cross multiply. So I'm going to end up with 3.4x is equal to 2.72 multiplied by 6.9. So that's going to end up being equal to 18.768. And then ultimately I would divide by 34. That's not 34. I would divide by 3.4. And I would get that my x value is equal to 5 52/100. So I know that DF is equal to 5 and 52/100. Now, I do want to point out, I could have set that proportion up differently and I would have gotten the same answer. So, and again, this is sort of how you prefer. I could have put the short over the long of this triangle, 3.4 over 6.9, over the short and the long of this triangle, 2.72 over x. And if you look, technically the proportion is different. But when you go to solve the proportion, you get that 3x is equal, 3.4x is equal to 6.9 times 2.72. It's the exact same problem mathematically as up here. You get that 3.4x is equal to 18.768. And again, you would divide by the 3.4. So some of you are probably like, well, that's ridiculous because I'm just going to do what I did yesterday and I'm going to find the scale factor and I'm going to do that and everything's going to be perfect and happy. Well, on the next question, you're going to see why the proportions are necessary. And again, the only reason that we were able to do that math with these two triangles is because the two sets of congruent angles told us that these figures were similar. So now we're going to go to example 3. And we know that they're similar because A and C, or A is congruent to H and C is congruent to J. So the two congruent angles mean that the triangles are similar. So it says to identify the similar triangles, find X and the measures of the indicated sides. So in this one, it's a little bit more complicated because I need to find the actual value of X here. Well, I know that this side length here, AB, is going to be proportional to this side length here because whatever scale factor has been applied has gone from this side length to this side length. They're corresponding. I've gone from one arc to no, one arc to no. So I'm going to put that x plus 1 over the side length of 3 there. Well, now I go to this next triangle. I know from my 1 arc to 2 arcs, I have x plus 5. And from my 1 arc to my 2 arcs, I have 6. So now I need to cross multiply. That's going to be 6 distributed to x plus 1 is equal to 3 distributed to x plus 5. So that's going to give me 6x plus 6 is equal to 3x plus 15. I'm going to subtract my 3x and get that 3x plus 6 is equal to 15. I'm going to move my 6 and I'm going to get that 3x is equal to 9. And ultimately that x is equal to 3. So I've solved for x there, set up a proportion, used equation skills there. I put my corresponding side over my corresponding side, my corresponding side over my corresponding side. So now to find AB, I do x plus 1, so that's 3 plus 1, so that's 4. And when I find AC, that is 3 plus 5, which is 8. So that there will be your missing values. So again, these questions are all about setting up proportions to be able to find your missing values there. All right, last question here says a person who's 5 foot 10 inches tall casts a shadow that is 3 feet 6 inches long. At the same time of day, a flagpole casts the shadow that is 12 feet long. To the nearest foot, how tall is the flagpole? All right. So we've got things in feet and inches, but it asks us about things in feet. So I'm going to convert everything into feet as I get going. But basically it says I got a person that's 5 feet tall casting a shadow here. So this is going to be my person. So they're 5 feet 10 inches. This is going to be their shadow. Excuse me. That is 3 feet 6 inches. And it tells us now that at the same time of day, so this part is basically supposed to tell you that like the angle of the sun is the same. So therefore we can assume that these triangles are similar. So it tells you that you have a flagpole that casts a shadow that is 12 feet long. So basically, what it's saying here is like your body forms this 90-degree angle with the ground. So you've got your height and the leg here, and the flagpole's up here, and it also is going to form this 90-degree angle with the ground, and then it's going to have a shadow. So basically, we're supposed to assume, based on the fact that it's the same time of day, that this angle up here is the same as well. And that would mean that we are dealing with similar triangles. So we need to find the height of the flagpole, which is going to be the vertical distance there. Flagpoles don't lay on the ground. So I know I've got I want to find X, got 12 feet here. Well, 3 feet, 6 inches. 6 inches is half of a foot. So that's 3.5. This is 5 feet, 10 inches. Well, 5 feet, 10 inches, that's 10 over 12. So that's 5 over 6. And 5 over 6 is going to give you a decimal that is it is a repeating decimal. So we're not going to be able to use that. We're going to have to say 5 and 5/6 there. And you should know that when we go to deal with this, we're really going to need to turn it into an improper fraction. So 5 times 6 is 30 plus 5. So this is really 35/6 feet. All right, so we're going to go to set up our proportion here. And you're going to want to have a calculator to deal with your fractions and your decimals and stuff. But we are going to put the height of the person, so that's 35/6, over the height of the flagpole, so that's X. I'm going to put the shadow of the person over the shadow of the flagpole. So I'm going to go ahead and cross multiply. I get that 3.5x is equal to 35/6 times 12. So I get that 3.5x is equal to 70. So now the only thing that I have to do to continue solving here is to divide by 3.5. And when I divide 70 by 3.5, I get that the X value here is 20. So that means that the flagpole is 20 feet tall. So I hope that that makes sense as you're using these proportions. The proportions that we set up are going to continue through the next next 4 lessons. So your homework for tonight or through the weekend is going to be to go ahead and go to page 122. And on page 122, you'll see these questions here. And I want you to go ahead and do 1, 2, 3, 4, and 5. And on 1, 2, 3, 4, and 5, they are just asking you to determine whether each pair of triangles is similar. So what you need to do is you need to think about angle criteria. In order for them to be similar, it means that 2 of their angle measures within have to be similar. So you want to look at each one of these. And then if you know that they're similar, you need to name how. So for instance, this one would just, because we already know we've got 2 congruent sets, that A, B, C, no arcs to 2 arcs to 1 arc, would be no arcs to 2 arcs to 1 arc. So it would actually be congruent to Z, Y, X. So be careful about the ways that you are naming those triangles. And as you are going through this, please, like, for this one, when you go to record it, I want you to write angle C is congruent to angle X. Angle B is, I don't know why I'm not writing that because I put my pencil down. So like angle C is congruent to angle X, and the angle B is congruent to angle Y, which tells you that triangle ABC is similar to 1, 2, ZXY. And remember, if I say ABC, ZXY is the only way that I can say that because that's the only one that goes from no arcs to 1 arc to 2 arc. So do that for 1, 2, 3, 4, and 5. And again, they're not all necessarily going to be similar. Then for number 6, you're going to go ahead and use that same logic that we used when we're setting up our proportions and solving for different values. So that's the same for 6 and for 7. And again, it's dB, the whole height is x plus 5. You don't have to deal with the x plus 1 within that. The whole height is x plus 5, and here the whole height is just x plus 1. So that's the information you need. You've got the heights of each triangle, and you've got the hypotenuse of each triangle. Then for 8 and 9 and 10, those are, well, these ones are similar to the question about the flagpole and the person. And then the last question here, don't make it harder than it is. It is as easy as you think that it is. So again, those are going to be, that's your homework. So that was pages 122 to 125, those 10 questions there. Then on Monday, we will go over those 10 questions during a Zoom meeting at 9:15. And then we will continue along with our lesson. So Monday's lesson, again, will be taught at 9:15 on Zoom, and we will go over these solutions and move into our next little mini unit, which is asking us to work with our different little side angle side similarity statements as you're dealing with these. And so that'll be exciting. All right, so I will see you guys face to face on Monday morning. And for now, that is all. So I hope that this is not too complicated. Go ahead and get working on this, and that is that. Have a lovely weekend. Take a break from school. I hope that you've caught up so you don't have to do makeup work this weekend. And if you've stayed on track, then you take a little break. All right. Bye, guys.